sense now.
If the ventilator gives a breath, because if I have a respiratory rate of 20, if that, every 3 seconds, there should be a breath. And if that patient hasn't triggered a breath within that 3-second time frame, the ventilator is gonna give the breath, therefore it was time triggered by the ventilator. But if 2.3 seconds in, the patient says, I need a breath, the patient took the breath, you'll see a deflection, either in the pressure or the flow. And that would be the patient's triggered breath, okay? So in volume control, what's ending the breath? What cycles the breath off?
Volume.
For which one are we talking
So
about?
volume control,
When you reach the tidal volume.
when you reach the tidal volume, right? Okay, so it's gonna be volume cycle. Okay, you hit your volume, boom, you're done.
Okay, that's why I figured out the question that I had, so you don't have to go back to it, because I already know what I did.
Okay, so I can erase that?
FYI, I
It's
didn't
done.
take it out of the parking lot.
Yep, that was in the park.
I was forgetting to divide by 60, so that's what I was doing wrong.
And it's easy to do.
I think you just went over my math correctly.
Okay.
Yeah.
Could we also determine, time constant from this?
Yeah.
You can turn it up, yeah.
Yeah, like
You
that's
just
what
times
my
whatever you
teacher
got for the
said.
resistance.
In the box,
You just times the resistance times the compliance. that we
Okay.
got.
And when you're doing a time constant, you have to make sure that your volume on, when you did your compliance, is in liters. Okay, so if I calculated compliance as, let's just hypothetically say 40 mils per centimeter of water, when I go to do my time constant, this has to be in liters.
How do you change
Oh,
that?
yeah, that's where I was messing up.
Is that
Oh,
just the
I made a
liters?
permanent one because people kept asking me to draw this.
Oh, is that the decimal step?
So this is the step, right? Okay, so I'm in milliliters, right, down here, and I wanna convert to liters. So I'm gonna go 1, 2,
Oh, yeah, the
3
stairs.
steps to the left. So therefore, here I'm at mils, here's 4,000, here's my decimal. If I take 3 steps to the left, 1, 2, 3, it would be 4 liters.
I have a question
Yes.
that, so about, it's like kind of about this, but, because when you're doing compliance, is it always the decimal point, like, should it always be in liters and not milliliters?
So, we go back and forth.
So, but like, if I'm trying to figure out the time constant.
What do you think's the
do I?
Time constant always has to be done in liters.
So it would have to be with the decimal point.
Well, what if I had, so, I'm not sure if you're, so if I had 28 mils per centimeter of water, but I could also have 28.3 mils. So there's a decimal point there.
No, but it's a decimal, the whole number is a fraction, it's not a whole number, it's a fraction.
This is.
I know what you're saying.
That's not in liters.
No, but to be in, if I had this, then I'd be 123.028.
That's what I'm asking,
Yes.
is compliance always a fraction, when you put it in liters?
Even a
It's,
decimal.
that's not a fraction.
Decimal.
Well, it's a fraction of a whole number.
So
Oh,
it's
it's a
always, does it
That's a
always have to
fraction.
be?
I know what you're saying, and I think for you would be easier
That's the
to just do it
decimal.
that
That's
way,
a
so that
decimal.
way.
So you're talking about, does it always have to be in a decimal?
It always will be in a decimal,
Yeah, same.
yes.
Or when you're saying fraction, you want to use.
I just, because I'm not, fraction to me is different, you know what I mean?
I just meant like a fraction, like just whatever.
Part of a
one you
number.
did. Yeah, it's
That's
not
what
the
you
whole
mean.
number, it's a portion.
Okay. It's gonna be, how
So
would
it
we
has
say
to be-
less than 1?
Yeah,
Is
so
that what
it's
you're
always
looking
gonna
for?
be less than one, question mark?
Well,
I think you should just.
most likely, yes.
Okay, so.
Because I can't imagine anyone having a compliance of 1,000 mils per centimeter of water, which would be a liter. So yes,
Okay.
let's say it will be less than 1. Okay, all right.
So we should always put it in liters.
Yeah.
So when I multiply compliance by resistance, they should both be in liters?
Yes,
Okay.
yes. Okay,
I get it now.
we good on that? Alright, so there's one more waveform to look at. So we had pressure control, volume control. Okay,
How long is this freaking
when
thing?
it comes to,
Something question.
flow control, we're not
She
gonna
doesn't
be
realize
thinking
how long it's
about,
gonna take.
I know what the question was about pressure support and stuff.
She doesn't know what
For
it
right
is.
now, okay, the way current ICU ventilators work, there's no, inside there used to be a piston, okay? There was a certain volume, so the piston kind of expanded or contracted, a certain volume would go in, and then when it was time, the breath was triggered, it would push that volume of air out, okay? Most vents are actually what they're considered to be flow control, okay? But for our purposes, we're really setting in a volume, so therefore, the ventilator is, we're gonna call it volume control. Flow control looks at flow only, and you have to set an inspiratory time. Most of you in here will never use a ventilator, including myself, that is considered a true flow control ventilator. We're just not gonna. Okay? So on flow control, how it works, okay? If I set 30 liters per minute, okay? Let's convert this first to seconds. Okay, so 30 liters per minute is equal to how many liters per second?
Divided by 60.
So 30 divided by liters per minute by 60 seconds per minute. Okay, what we're gonna get is 0.5 liters per second, right? Okay, so if I deliver that breath, okay, so if I set my inspiratory time, okay, to 0.5 seconds, how many liters am I gonna get?
30. Oh, what?
Okay, okay, I set my ventilator at 30 liters per minute. So 30 liters per minute of air is what's gonna come out of that ventilator, okay? Let's just make this easier, convert it to seconds. So in 1 second time,
0.25.
0.5 liters is gonna come out. So
Oh, in half a second.
0.5
so
liters
0.25.
per 1 second comes out, right?
Yeah.
So if I divide that,
0.25, yeah.
okay, so that means I'm gonna get 0.25 liters per.
This is a lot of math. So we
We
actually
haven't
have
gotten to
know
the
how-
math yet.
I wanna explain, I wanna explain the flow controlled thing, okay? So in flow controlled ventilation, okay, you set a base flow, the flow, and an inspiratory time. And dependent on that will give you your volume, okay? Okay? The flow is constant. You are estimating that based on normal compliance, normal resistance, okay, that if I set the ventilator for 30 liters per minute and I let that run for half a second, it should deliver somewhere around 250 mLs or 0.25 liters.
And is
okay?
that volume?
This is flow,
Okay.
because it's the only thing I'm setting is flow. This is my estimated tidal volume. Based on the flow and how much time I'm gonna let that flow go to the patient, I should get a tidal volume of about 250 mLs. But depending on the patient's compliance and airway resistance, volume and pressure are variable, okay? So in flow controlled ventilation, pressure will vary with compliance. Volume can vary with compliance. The only thing that's gonna be consistent is that flow, right, a little high, okay? So in flow control, pressure is variable. Volume is variable. Flow is constant. So one of those images that I gave you in your packet
Flow is constant.
okay, so pressure is varying, it's up and down, volume is up and down, but the flow is the same.
That's what I was trying to figure out.
Okay, so that's flow controlled ventilation, okay? Even though the modern day ventilators do flow in time, we are really setting a volume, right? Okay, so it's gonna adjust the I time to get that volume that I want based on the,
Are we gonna need to estimate that tidal volume?
nope, I don't believe so, not on this.
Cause I have you go back over.
I can't remember putting it in, I can't remember putting that in there.
Okay. I asked her if we were gonna have to estimate.
Yeah, but this is how the ventilator works. When I'm in flow control, I set a base flow and an I time to give me an estimated tidal volume. Based on compliance and resistance, that's gonna vary. Okay, the only thing that's constant is the flow. Okay? Right. Is everybody okay with that? That's about all you need to know for that. Okay? Alright. Anything else on waveforms? Flow and volume are variable, we are in pressure control, and the limit is the pressure. Okay. What's going to, cycle the breath off in pressure control ventilation? Time, however much I set that inspiratory time, right? Okay. For a machine trigger, okay, in pressure controlled ventilation, what is gonna be the trigger for the ventilator to give the breath? Time. Okay. Alright,
I'm just going with
you're on a roll.
No, I know, I think,
Good
I have
job.
to see it to like.
Okay.
That was for pressure
For
control.
pressure control. Now let's go to volume control. In volume controlled ventilation, what is the limit? Volume. Okay. What's variable in volume controlled ventilation? Pressure.
Just
Well,
pressure.
just pressure. In volume controlled ventilation, only the pressure is variable. Flow is constant along with the volume. Okay, and when you go into your clinicals, when you're setting volume ventilation, you are setting a volume and you're setting a constant flow, basically, right? Have you done volume ventilation, okay? What is the trigger for the ventilator in volume control? What will trigger the breath to start? Time. So if that cycle time is coming to however, when that next breath is supposed to be, if the patient hasn't triggered it, right? Then it's time cycled. Okay, triggered. Okay. What is a cycle for the breath? When it stops inspiration, therefore, what's the volume? It's gonna be volume cycle, right? Okay. We have a safety setup though on volume control ventilation, okay? If I set an alarm, so if I'm in, let's say I'm in volume ventilation, okay? My volumes are the same, okay, my flow is the same, and I set